Welcome to the last video in Section 2, Supervision and Monitoring. In the previous video, we discussed sending a message to an actor via tell and ask. In this video, we will take a look at what's supervision, the supervision strategies in Akka, what's the monitoring, and finally, we will implement some actors to understand supervision and monitoring. Let's start. Supervision describes a dependency relationship between actors. The parent and child relationship. The parent is unique because it has created the child actor, so the parent is responsible for reacting when failures happened in its child. I think you remember this diagram from the second video where we had described that we had three choices if an exception was thrown. Resumed work, stopped, restarted. But we didn't discuss who was responsible to decide what's the better choice. The simplest and only answer is the parent for the actor. When the parent receives a signal failure from one of its children, depending on the nature of the work to be supervised and the nature of the failure, the parent has a choice of the following four options. Number 1. Resume the child, keeping its accumulated internal state. Number 2. Restart the child, clearing out its accumulated internal state. Number 3. Stop the child permanently. Number 4. Escalate the failure, thereby failing itself. This means I can't handle this failure, so I'll propagate this failure to my parent. Just note that supervision-related parent-child communication happens by special system messages that have their own mailboxes separated from the user messages. This implies that supervision-related events are not deterministically ordered relative to ordinary messages. In general, the user cannot influence the order of normal messages and failure notifications. Now, let's list down the supervision strategies that come with Akka. We have one-for-one strategy and one-for-all strategy. Simply put, in one-for-one strategy, the parent will apply his choice only on the failed child. On the other hand, for one-for-all strategy, the parent will apply his choice on all children. The default strategy is one-for-one strategy, and normally you should be using it. Now, let's check out what monitoring is used to tie one actor to another, so that it may react to the other actor's termination, in contrast to supervision which reacts to failure. In other words, actor A monitors actor B, because actor A wants to receive a signal when actor B is terminated. Now, let's get down to business. Coding. We have two examples, supervision and monitoring. In the supervision example, we have Aphrodite and Hera as actors. Hera is the parent of Aphrodite. In Aphrodite, we implemented lifecycle hooks to understand what happens when an actor stops, resumes, and restarts. Let's add supervision strategy in Hera. We will override supervisor strategy. When he receives a failure signal with a resume exemption, he will resume his child. When he receives a failure signal with restart exception, he will restart his child. When he receives a failure signal with stop exception, he will stop his child. For any other failure, he will send this failure to his parent. Here, we will send resume the message to the Hera actor. Let's run to show the result. Now, let's send a restart message and run. Yeah, these are our messages. Aphrodite, pre-start hook. Hera, received restart. And this is the exception thrown, and then Hera restarts Aphrodite. Aphrodite, pre-restart hook. Aphrodite, post-stop. Aphrodite, post-restart hook. Aphrodite, pre-start hook. Aphrodite, post-stop. Now, let's try to stop the message. Yeah, that's the result we expected. Excellent. Now, the final thing for this video is an example on monitoring. We have a simple example, just two actors here, Ares and Athena. The Ares actor takes a reference to the Athena actor and will monitor it by invoking the watch method on restart. When he receives a terminated signal, he will stop himself. Now we have the Athena actor. He is a simple actor. When he receives just a message, he prints this message and stops himself. Let's run our app. Awesome! That is the expected result. Good job! We have now reached the end of section 2. Take a look at what we've covered. We saw the actor system and its components. We then discussed the actor components and life cycle. We started coding some actors to understand the actor definition and their creation. We sent messages to the actor via tell and ask, supervision and monitoring. See you in the next section, working with Akka basic tools, where we will implement router actor, stateful actor, and change the actor behavior at runtime.